Okay. So apa khabar semua? Sihat? Long time no see. Is everyone okay? Sihat? Semua kat rumah kan? Alright, so welcome back to our virtual class, right? Virtual USM. So we're gonna continue with our first class today for this semester, semester 1. Your final year in your undergraduate. So are you excited with your final year now? Being in the final year, students? Are you excited? Ataupun tak ada apa-apa? No, not excited. Okay, so let me just share the slides. Not at all excited. Aku tak excited tu, Gijan. Karena sebab COVID I love you so much, really. Good to know that. Okay. Online nak balik SM. Yes, I understand that. Liana. Lecturers pun looking forward for face-to-face lectures, face-to-face classes, but no choice. We have to still be on online teaching, at least for the next few months. So the instruction as of now is the online classes have to be conducted until December. So, but you are already scheduled to come back after mid-sem break, right? So that's gonna be on the 7th of December, I think. So at least half of your class will be online, and then another half will be for face-to-face. Hopefully everything is okay, inshallah. Okay, so let me just share the slide for this course introduction today. So by the way, did you get the slides on Elon? Okay, good. You also saw my announcement, right, on Elon? You dapat kan? Email notification kan? On the link and everything for this particular class. Okay, good. So let me now open the slides and share the slides. So let's go through the slides together for this introduction. It won't be so long for today. Okay, hold on. Participant chat. Okay. Right. Let me know if you can see the slides on the screen now. Can see? Okay, good. So let's get started. I'll just move this one to another. Okay, cool. All right. So this is ZAT487 semiconductor fabrication processes. So basically, I've already briefed you last time during your 386 on what it's gonna be like for this particular course. So for 386, we have learned on the basics of physics for semiconductor. Tolong mute siapa yang tak mute. Please mute all. Okay, good. Thank you. Tolong mute siapa yang belum mute. Okay, I've briefed you last time on what's the contents gonna be like for this particular course. So you have learned last time about the physics of semiconductor devices, where we already covered materials. In fact, inside the material, Fermi level, valence band, conduction band, Fermi Dirac distribution, so on and so forth, until the very end of the course, where we covered semiconductor devices like solar cells, transistors, detectors, FET, IGBT, and many more, right, in your presentations. So in this course, ZAT487, you're gonna learn on how do we fabricate the devices. So we have learned about the transistors, about solar cells, and some other devices. So on the inside, on the operation, on the physics, on the limitations, so on and so forth. So this particular course is gonna teach you about how do we actually fabricate the device. So how do we realize if you see the wafer here, down here is the wafer. How do we actually um, translate bare wafer yang kosong, kat bawah ni actually wafer yang kosong originally, into a wafer with full of patterns or chips or devices. So kita akan belajar how do we actually do the process and what is actually the process that's needed for you to realize the device. Okay, so we're gonna focus on integrated circuit fabrication in particular. So if you talk about integrated circuit, it's all about the chips that we have in our phones, laptops, some other devices that actually runs the products. Okay, runs the products. So this wafer fabrication, we also call it as a wafer fab in abbreviation. We call it wafer fab usually, or wafer foundry. Some people call wafer foundry, some people call wafer fab. Or generally wafer fab ataupun fabrication process ni, it sits in the front end of EE punya value chain. EE means electrical electronic value chain. So maksudnya nanti saya akan share with you sometime in the course. Semiconductor ni dia ada dalam satu value chain. Dia ada ekosistem semiconductor. So value chain tu dia berada dalam EE ecosystem. EE ecosystem ni macam satu yang besar. So you can have a look at Penang, Kuala High-Tech, Pry, Auto City. So semua ni berada dalam EE industry mainly. So dalam EE industry ni we have semiconductor as a subset. So dalam semiconductor tu dia ada front end sampai back end, right? Front end ni is mainly wafer fab. And in fact, before wafer fab, we have the ink icing, wafer cutting, wafer cleaning, then wafer fab. I'm going to go through the material later on, but this is a brief. Then sampai dapat wafer yang dalam gambar ni with full of devices, full of chips, and and eventually wafer fab is going to send the wafer to back end semiconductor companies to do the cutting, packaging, and package the whole device as a chip. So chip ni dia akan eventually go onto the board, motherboard ke whatever board, PCB, dan masuk dalam produk yang kita pakai lah, phone and laptop and some other and whatnot. Right, so that's the whole idea. So basically bila you dah belajar physics of semiconductor devices in your 386, so now you're going to learn on the processes required to actually fabricate the devices. So by the end of this course, you're going to know the whole chain, the whole process, right? So what you're going to learn here, I put here on the slide, is a picture of integrated circuits on the wafer that you've seen on the previous slide. So this is the zoom in version of the chips. So if you zoom in, so they're going to look like this, right? So nanti kita akan tengok when you zoom in further, you're going to see the details of every single architecture within the chip. How do we actually make them, right? Okay, this is just an example. If you look at A8, siapa yang pakai iPhone? Izian pakai iPhone kan? So do you know what's the chip inside your iPhone now? Izian? Anybody else who's using iPhone? What's the latest chip in your iPhone now? Any idea, Izan? Or somebody else with iPhone? No? Anyone else? Do you guys know what's the chip in your iPhone? Ataupun if you're Android user, what's the chip in the Android phone? Okay, go back and check for yourself in order to appreciate the content of this course and how is it related to your what you call devices, right? So if you look at this A8 chip in iPhone, right? So So ini bukan yang latest one. I think the latest one is A12 or A13. A12 is bionic chip. So go check on the latest chip as well in the iPhone. So if you look at this particular A8 chip, so it's actually fabricated with critical dimension ataupun line tu, you tengok kat gambar kat bawah ni. The CD there is the line, the smallest features lah, if you like, that you have to fabricate in the chip for it to work as the way you want it to be, right? So this particular A8 has CD or critical dimension to line width, width yang process fabrication to kena print the smallest one down to 15 nanometer, for example, in this case. So it can only be done by EUV lithography. EUV here means extreme UV lithography. So we're going to learn about lithography process and what types of lithography process do we have in the market now. A13 bionic chip, right? A13 bionic chip. So possibly A13 is the latest one. Go check out later on. So well, you can see here. So let me just play the YouTube video for you to watch. Let me go back to this YouTube. Okay. Ready. Okay, can you see the YouTube page now? Nampak tak YouTube page sekarang yang saya tengah play? Okay, good. Okay, nampak good. So let's just go into your iPhone and see what do I mean by the current slide. Okay, so it's just a 30-second video, but it's very meaningful for you to understand the content of this course. So let's just zoom in into your iPhone, and that's the chip, A8 chip. So where's the location we're going to look at? So it's one of the many chips, perhaps thousands of chips on the wafer. Zoom into the chip, zoom into the details of the chip. Right, you look at the details there. So that's it, right? So that's details that you have to learn how to fabricate in this course. Okay, so you have to learn, you're gonna eventually learn how to fabricate the details within the chip in this course. So let's just play one more time. So it's part of the many thousands of chips in the wafer, right? Wafer is typically about, if you look at Malaysia, it's 8-inch in diameter, or 200 mm, or 20 cm if you like. Or if you look at the giant wafer fab, they typically use 3 mm or 30 cm, satu pembaris panjang punya diameter, or 12 inch, right? 12-inch technology to do the semiconductor fabrication. So let's go back to the slide. So back to the slide. So you can see the slide, right? Okay, nampak? Okay, so these will be the details that we're going to learn on how to actually do the fabrication process along the way in this course. Okay, so we're going to learn every single process required for you to get this small architecture in the chip. So bila you belajar on the wafer fabrication ni, is actually wafer fabrication ni, or integrated circuit to be specific, is the highest or the most complex process that you will learn. The moment you go for other semiconductor industry like solar cells or LEDs or solid state drive, all the processes involved in these other companies other than wafer fab, they are the simpler version of the processes you're going to use in wafer fab. Maksudnya kalau proses you belajar dalam wafer fab is like 200 different steps. Process dalam solar cell is probably like 8 or 9 processes in total, and SSD probably, I don't know, blah punya process. But for integrated circuit in particular, you're gonna have like 200-300 layers for the chip to work. So Bila you dah belajar wafer fab punya proses, so bila you pergi ke other industry, for example, if you want to join OSRAM for LED or WD for solid state drive or Jinko or JA Solar for solar cell, the processes involved is gonna be a lot simpler. So maksudnya tak ada hal lah, basically you nak belajar the process balik. Sebab you dah belajar IC fabrication anyway. So it's gonna be a lot simpler. So I would like to put that into perspective so that you know proses yang belajar ni dekat other industry, how does it look like? Because the focus is in this course is going to be on the integrated circuit in particular. But I'm also going to mention here and there or a couple of topics on other devices as well. So if you look at this Huawei Kirin Huawei punya chip 1990 990 5G chip is the latest one. So it uses CD of 7 nanometer. So that means kalau you tengok dalam slide yang tadi tu, instead of 15 nanometer critical dimension, it's going to be sliced into half or 7 nanometer. So it's going to use TSMC 7 nanometer process. TSMC is actually the name of the giant semiconductor wafer fabrication in the world. World number one, world king. So the full name is Taiwan Semiconductor Manufacturing Corporation. Kita dah pun go through dalam presentation kan hari tu in 386 where some of you did actually do presentation on TSMC and EUV and FinFET process last time. So this particular chip, 990 5G chip, uses 7 nanometer process on EUV lithography, where the exposure wavelength is going to be within 10 to 14 nanometer only. So you can see from here, before you actually learn lithography, for you to get critical dimension of 7, you need to use exposure wavelength dalam ni EUV system ni. EUV system, ni EUV system saya conteng kat sini ni. So it's yellow color in yellow environment. There's a reason for that. Why is it in yellow environment? Dia tengok kat lampu semua kuning kan. So it has to be, there's a reason for that. Okay, bukan suka-suka nak pakai lampu kuning. So I was in lithography last time when I was in Cetera, and the best in Cetera is only down to argon fluoride technology, which uses wavelength of 193 nanometer. So with 193, we can only print down to about 100 nanometer with good resolution. So below 100, Cetera cannot do because the exposure system has to be changed to EUV like this, and EUV is like hundreds of million per piece. Okay, we're going to learn that more. So with this TSMC Kirin 990 5G chip, you can find 10.3 billion of transistors in 200 mm squared of area. So dalam 200 mm, so there are about 10.3 billion of transistors. So trial production has just begun. Mass production is in Q1 2020. So they have just started a couple of quarters ago with this 5G chip by TSMC. Okay, wafer fab in Cetera, the capability is down to 100 nanometers. So you can see the level of our wafer fab in comparison to the king of the world, which is TSMC. So we can only do down to 100 nanometer, and they are now doing 7 or in fact 5 nanometer technology. So that's like 20-fold reduction in terms of critical dimension. Okay, so there I can do down to 100 nanometer, but most of its product is like 100 plus, 200 plus nanometer. Some are in fact in microns, depending on what types of devices do you need to fabricate. Okay, so other than Cetera, do you know any other wafer fabs in Asia? Siapa tahu ada wafer fab lain kat Malaysia? Any idea? Mana lagi kita ada wafer fab? Or what other examples of wafer fab do we have in Malaysia? Siapa tahu? Anyone else? Any idea? Lena, any idea? In Kuliah Matek? Infineon, yes, exactly. Good, Azika. Infineon, sebelah Cetera aja. So that's why kawan-kawan saya kat Cetera tu kadang-kadang tukar kerja pun pergi Infineon je, tukar parking sebelah je, tukar parking, tukar cubicle. So we have Infineon doing automotive chips. We have Mimos in KL, but the technology is not so great. They buat simple chip fabrication only. We have Fuji Electric, right? Fuji Electric in Kulim High Tech as well. We have Osram, Kulim High Tech, and Penang. So Kulim, if you look at Osram, for example, Osram dia buat apa ni solid state lighting and LED. So Osram dia punya back end processing, yang packaging and everything, I mean almost done punya product is in Penang, but the front end process where you do the epitaxial deposition, all the crucial first steps for LED fabrication is in Kulim, right? So that is also a wafer fab. So we have Celtera, Infineon, Osram, Fuji, Mimos, right? But we also do have X-Fab in Sarawak, in Kuching, right? X-Fab. It's also a wafer fab, okay? So at the end of this course, you should be able to, so these are 4 course learning outcomes that have to be attained by this course at the end of the 14 weeks. So you should be able to analyze processes involved in fabrication of wafer and semiconductor devices. So basically you should know, after you have learned all the processes involved in the fabrication, you should be able to understand each and every single process for wafer and semiconductor fabrication, for semiconductor devices. So you should be able to know which process is needed for IC, which processes are needed for solar cells, which processes are needed for LEDs and some other devices. Even though the focus for this course is mainly on the ICs, but I want to have a grasp of what are the processes involved for some other devices as well. So because I told you just now, for some other devices, the processor involved are going to be a lot simpler than IC. Okay. So the second one is you should be able to fabricate semiconductor devices on silicon wafer based on fabrication processes. So we hope to do this in the second part of the semester, where you actually have to be in no lab to do not the completed device, but you have a taste of doing fabrication. Perhaps one group will be assigned to one specific process, and then you're going to end up doing fabrication and eventually a presentation of your results based on your groups on different processes. Okay, so let's hope that everything is okay by the mid-sem. Hopefully, inshallah, I hope, because for the last few batches that I taught in this course, they get to do the fabrication during the second half. So mainly the last 4 or 5 weeks, where they actually spend some time in the lab for like 2-3 weeks, and then preparing for presentation the final week. So mainly the first part of this semester on the teaching in the class online in this case. So the second part, if everything is okay, you're going to be in the lab, okay, doing the actual fabrication. So the third objective or learning outcome is should be able to present semiconductor fabrication processes clearly and with confidence. So you have done your FYP presentation. So I think by the time you completed your FYP, you have got extra confidence. Yes or no? Ke sama aja dengan before FYP? Do you actually gain your confidence after FYP in terms of presentation and hands-on lab work, simulation, whatever you do? So, what do you say? Do you actually gain more confidence? Or no change? No? No news? A bit? Okay, good. A bit is good already. So as long as you've learned something and you've improved your presentation, what we call quality, confidence, so on and so forth. Sorry, Jingwei is not signed in. Let me go back to the, hold on here. Waiting in the lobby. Hold on, give me a few seconds. So, okay? Sorry, I didn't realize you're waiting in the lobbies now. So let me go back to the slides. Okay, present semiconductor fabrication processes clearly and with confidence. Hold on, participant, chat. Okay. So also, you should be able to organize information related to semiconductor fabrication processes. This one will mainly learn in your assignments later on. Okay, you have to organize the information. Okay, so number of lecture per weeks, we're gonna have 4 lecture per weeks. 7 weeks before the mid-sem break, 7 weeks after the mid-sem breaks, altogether 14 weeks in our academic calendar. Lecture schedule, so forget the location for now. So Monday is going to be 11 to 12, so now on all on WebEx. Wednesday 2 to 3, let me know if you have clashes. We can discuss and readjust if possible. Thursday 2 to 3, Friday 11 to 12, so no class on Tuesday. So any clash, I heard you have some clashes, right? Ada clash tak dengan some other classes? You can adjust now. Anyone yang ada clash? All right, Wednesday. Okay, so far clash Wednesday lagi apa lagi? Let me know. Monday, okay, Monday. Sorry, Wednesday clash dengan kelas apa? Let me know. Siapa tadi? Hold on, let me check. Wednesday is okay, Shamim. Wednesday dengan kelas mana? Oh, saya tulis je. Wednesday with Monday with. So okay, Wednesday university course, is it? Okay, Wednesday university course. Monday university course juga. Monday university course ke? Betul ke? Okay, right. So university course. So only Monday and Wednesday? No other days, right? Okay. So let's see on. So okay, hold on. So sorry, may I know how many on Monday again? 2? Is it 2? Okay, kalau you clash Monday, you say Monday. So supaya I can count the number. Okay, Monday, please type Monday. This I can kira how many of you. And 2 kan, is it? Okay, Monday, Chingwei, who else Monday? Jenny tadi Monday. 2 Monday, who else? 2 orang je Okay, 2 Monday. Monday 2. Okay, Wednesday. You just type Wednesday. 1, 2, 3. Nabila. Oh, banyak juga ni. Okay, 1, 2, 3, 1, 2, 3, 4, 5. 5 Wednesday. Okay, so let's go through Monday first. Monday. Yeah. Monday, do you have a class in the morning? Monday, okay, kelas kita 11-12. Okay, so Monday you had a class 9 to 10. So Monday tadi kelas 2 orang. So Monday 10 to 11, is it okay for everyone? Can. Okay, siapa yang lah tak boleh Monday tak boleh. 10 to 11 cannot. 11 to 12 is now. 12 to 1. Oh, class is 10 to 12. So how about Monday? Oh, you want Monday afternoon? Monday afternoon is okay. How about Monday 2 to 3? Ada kelas juga. 2 to 4. Monday cannot. So Monday is out. Okay, Monday gone. So basically Monday gone. How about Tuesday morning? Can. Siapa yang tak boleh cakap? How about, okay. Let's say Tuesday 10 a.m. Is it possible for everyone? So kita reschedule Monday to Tuesday. Okay. Ada yang tak boleh, please let me know. Tuesday 10 a.m. So tak ada cannot. Tak ada cannot means okay ah. Tak ada ah. Betul lah. Okay then. So all good. So now we reschedule Monday to Tuesday 10 a.m. So class on Webex still okay. Nanti bila second half, I'll see how to book the lecture hall and everything. As of now, still okay. So Monday is rescheduled to Tuesday 10 a.m. But no class tomorrow, starting from next week. Okay, done. Monday is done. So let's go to Wednesday. Wednesday sepatutnya 2 to 3. Can we do Wednesday morning? Say 10 a.m. Oh, 10 to 11 at the class. No, okay, good. How about 11 to 12? Okay. 11 to 12. Can. Okay. Siapa yang cannot, please? Wednesday 11 to ada kelas pula. Cannot. Alrighty. Wednesday 3 to 4. No, cannot. Or do you want it? Or can we have a class Tuesday 2 hours? Will you guys be free 10 to 12 Tuesday? If you want to combine 2 in 1. Oh, ada kelas pula, tak boleh. So cannot. So 11 to 10 to 11. So Tuesday maintain 10 to 11, okay? So ada kelas tadi. So sorry, Wednesday 3 to 4 ada yang tak boleh kan? Wednesday 3 to 4. Cannot kan? Ada yang cannot tadi? Betul. Confirm again? 3 to 4. Okay, cannot. Done. 4 to 5. Cannot. Alrighty. So Thursday. Alamak, Thursday dah ada kelas Thursday can we do 2 to 4 instead of 2 to 3? 2 jam class Thursday. Now 2 to 3. We can merge and make it 2 to 4. Okay, I would like to cannot. Done. Friday, Thursday is gone. Friday is sebelah 12. Can we do 10 to 12 Friday? So any cannot. 10 to 11 kan? 11 to 12. So we do 10 to 12. Cannot. Then we don't have any other choice. 10 to 11 cannot. Selepas tu dah Friday prayer, cannot. Or Monday, cannot. Tadi Wednesday yang problem. Wednesday 5 of you, okay. Wednesday. Wednesday morning. Wednesday 9 to 10, is it possible? Kau ada kelas tadi? Cannot. Wednesday. 8 to 9 boleh ke? Can you do 8 to 9? Boleh. Can. Can or can? Any cannot? 8 to 9 Wednesday. No. No. Tak ada pula. You ada kelas ke apa, Ishin? Cannot. Then where else? Wednesday. Or maybe. Oh, minor. Okay, all right. Wednesday. Tuesday 9 to 11. Hold on. Tuesday 9 to 11. Tuesday 9 to 11 tadi tak boleh kan? Kan ada somebody or something ah? Tuesday 9 to 11 is it okay? Ah, ada kelas tak boleh. Or Monday 12 to 1. Monday 12 to 1. Hold on. Monday 12 to 1, okay. Ah, okay, good. Okay, semua okay ah? No, cannot, right? Okay then, so looks like Wednesday tu kita bawa Monday 12 p.m. Okay, done. Okay, so saya recap ah. Your Monday class will be moved to Tuesday 10 a.m. Or actually boleh awalkan ke Monday sama. As long as we have 4 hours per week. Then Tuesday move to Monday 12 p.m. So maksudnya kita akan ada kelas Monday 12 p.m. Tuesday 10 a.m. Then Wednesday no class. Thursday, Friday maintain. Okay? Okay, nanti saya akan update the slide. Okay? So Monday, Tuesday no class on Wednesday. Kita ada 2 kelas awal, no class midweek. Thursday, Friday ada kelas. Done. Alright, let's move on. Class done. Okay. This semester is going to be on WebEx. In the first half of the semester, hopefully we can do face-to-face in the second half, right? Okay, so there's the link. The link will just be the same thing. So, okay, assessment. Alrighty. So, okay, so you have 4 core learning outcomes. So you can see from the list there are actually 4. Together with the Malay version as well. So we are going to address, if you look at this PLO column, so we're going to address PLO dengan PO sama. So PLO ni program learning outcome, or also equals to program outcomes. So in this particular course, we're going to address P01, which is on the knowledge component. So we're going to also address P02, which is on practical skills, which is going to be involved in the fabrication process second half. P04 on communication, where you're going to do your presentation. And then P10, digital skills, where you're going to do your assignment and compilation, arrangement of information for your presentation. So it's all together. So we're going to address 4 program outcomes in this course. P1, 2, 3, P1, 2, 4, 10. Okay. So we're going to go with 50-50. 50 for your final exam, 50%. And another 50% is going to be from your coursework. So instead of 60-40, so the school has just decided to switch to 50-50. So we're going to do 50% coursework and 50% final exam. So your 50% coursework is going to be made of 15% from your test, 15% from your assignment, and 20% from your presentation. Okay, so we're going to go to the next slide and you can see clearer. So you're going to have tests for 15%. So it's going to be 2 tests in the first half and in the second half, 7.5% and 7.5%, altogether 15%. So you're going to have written assignment, one in the first half, one in the second half, 7.5 times 2, 15%, and one presentation in the second half towards the very end of your course after you completed your fabrication and it's ready for presentation. And so then that's going to account for 10% of your coursework marks. So altogether, coursework is going to give you 50%, and you're going to have 50% from your final exam. And since it's 50% from your final exam, the exam is not going to be 3 hours, but it's going to be 2 hours instead. So the number of questions will be lesser, but we haven't decided on the number. But usually it's 4 questions. You have to answer all. 4 answer all, right? 4 answer all, yeah. So it's going to be 3 more or less. We haven't decided on that, but I'll keep you informed on the structure. Okay, so course outline. So you're going to learn about all these topics in this course. So we're going to start with introduction to semiconductor fabrication. I'm going to explain to you about the EE ecosystem, value chain, where is fabrication in the whole ecosystem. So growth of silicon ingot before we actually get the wafers. So macam bantal ingot. So we're going to learn how to do the growing process or the growth process, and how do we then prepare the silicon wafers to before we actually do the fabrication. So, and characterization of the silicon wafer before we actually do the fabrication as well. You're going to learn on a clean room, what makes a clean room, what is a clean room, what does it take to be a clean room, right? Then we're going to move on to the first process, thermal oxidation, which is going to give you a very thin oxide on your chip as the first process. Then we're going to move on to lithography process, where you actually do the patterning. Lithography macam process you stamp pattern on your t-shirt tapi electronically by light, right? Kita tak pakai Mohd tapi kita pakai light, cahaya. Or we also call this process as printing by light, photo lithography. That's why it's named as photo. Photo too is light, lithography is the printing process. So we're printing by light. Then we're going to do the etching process, where you actually drill or remove some of the unwanted material in certain regions of your device to be able to get a functioning device. Diffusion process, for you to dope your wafer to P or N type or P plus or P plus plus. Last time we've learned about the Fermi level, right? As you go for higher doping, you're going to go towards higher into the conduction band or lower into the valence band, and your wafer or your device is going to become more degenerate. So you're going to learn on ion implantation as well, or another method to do diffusion process, but this one is by implanting or embedding dopants into your device at a specific depth. And film deposition, you're going to learn about evaporation, sputtering, CVD, and some other processes. Process integration is where you're going to learn how do all these processes come together as an integration. So if you work as a process integration engineer, so you're going to oversee all these processes from A to Z, from the moment it started until the very end of the fabrication process. So you're going to oversee the whole integration. So S1, S1 before it comes as a one finished product. Interconnection and contacts, where you actually lay out the metallization layers, bond pad in between, in order to connect your wafer or your dies to the outer world for it to be probed and measured on current voltage system or something. Bonding and packaging, and then we're going to have a review class before your exam. So your exam entirely depends on the situation of COVID-19. So if everything goes well, hopefully, inshallah, then we're going to have your exam at your 50%. If it's not going well, so we need to wait for the government announcement. So we might end up with 100% coursework again. So we don't know at this point for sure. But we have a plan where the default will be 50-50, but worst case scenario is 100% coursework. But I can't tell you for sure at this minute, okay? So IC fabrication, if you look at the whole flow, so you're going to start with a wafer processing, and wafer fab is one that sits in the front end fabrication. So if you talk about wafer fab like Mimo, Silterra, Infineon, Fuji, Osram, so they're gonna be in the front end fabrication. So if you talk about end packaging, then you're gonna talk about Renesas, Fairchild, Intel, AMD. So where they actually take the completed wafer, already cut, already diced, into separate chip. Then they're gonna package the chip. Then you can nampak yang ada kaki, 8 kaki tu kan, or more than that in fact. Then put on the board, and then they're gonna do the back end packaging. So if you ask me which one is more challenging, then I would say that the front end is more challenging because you cannot see physically what's going on inside the device, but you have to probe under SEM or some other inspection machines. If you compare to back end packaging, you can see them because they are physical in nature, so you can actually book out the package and see what's actually happening inside. But when it comes to process like front end printing by light, so it has to be a lot of imagination involved, a lot of physics there as well. So that's why I think the front end is more challenging. Okay. So anyway, we're going to learn all these process from silicon ingot pulling, CMP process, deposition, lithography, etching, RTP until packaging in this course. So don't worry about that yet. Textbook, the official one will be bigger, Introduction to Microelectronic Fabrication. I think you can also find this online, PDF, if I'm not mistaken. So, yeah, lecture notes will be provided on eLearn just like the way I did on 386. So I'm gonna give you some supplementary videos as well, YouTube links as your supporting materials. Don't depend only on lecture notes. Just the way I went with 386 last time. Okay, student responsibilities and policy. I don't want to repeat this to you. You're a fourth year student. You should be well versed already with all the policies of USM. Right, online attendance. Don't miss it. But I think I can also do it the other way around because last time we missed a lot when we did online. I think last time eventually I managed to do your attendance just by looking at the log of WebEx. So as long as you are logged in for the certain period of time during the class, you are considered attending the class. Kalau let's say you are disconnected and then you come back on again, then you are considered attending the class. Kalau you are 5 minutes connected and then another 45 minutes not connected, if you have a problem, let me know. If you don't let me know, then you are considered not attending not attending. So you have to be fair to yourself. You have to be fair to the class as well, okay? So I don't want to lecture you on this because it's straightforward, right? You don't have to, you have to be lectured on this. Qualified for examination as long as you are attending the class, you don't have any problem, you should be okay. I'm not gonna ban you from any exam, from the test. Okay, why this course is important? I would like to relate this to you so that you can appreciate the course before you actually learn it. So you already learned the important concept in physics and devices in 386 last semester. So knowledge in fabrication will actually complement your previous knowledge. So kalau you belajar physics devices but you don't know the fabrication process, you macam doesn't say you cannot get a job kalau you tak belajar fabrication. Cumanya kalau you belajar fabrication, you have a plus. You have extra merit over your other friends who don't learn fabrication. Okay, but we do have students from pure physics hired by wafer fab as well. So walaupun dia orang tak belajar officially fabrication ni, but they are hired as well. So it depends on your overall quality as a student. Okay, what package do you bring to the company? But certainly, if you have this, you have an edge over other candidates. Hands-on skill during on semiconductor fabrication processes. Hopefully, you can do this in our second half of the semester. So, vital foundation to enter industry, whether it's IC industry or LED or PV or whatever. So, it's going to be a vital foundation, right? So, we are blessed with Semiconductor Valley in Penang, Kulim High Tech Park, Pride, Auto City. So, just in the right neighborhood. So, you have to, you have to take advantage of this, right? So we have EE subsectors in Malaysia. So as I said just now, semiconductor is a part of a big EE ecosystem that we have in Malaysia, electrical and electronic ecosystem. So if you look at this EE ecosystem, we have 5 subsectors. This one is divided by government. So I was involved in formulating the roadmap for the next 10 years for Malaysia 2 weeks ago in Penang. So this is the 5 subsectors categorized by the government. Okay, so we have semiconductor, we have optoelectronic and LED, we have solar PV, we have system electronics. So we have manufacturing related services. You can read the details there. So if you plan to work in EE industry or semiconductor in particular, you will probably be end up with in either one of these subsectors in Malaysia, right? So we'll probably end up with semiconductor, or opto, or PV, or these other 2 subsectors. But it's huge. Overall, the whole ecosystem is huge. So that means the opportunities are also huge for you to embark on. Right, we're almost done. Malaysia's strategic hub for semiconductor manufacturing. Kulim High-Tech and Penang are the nearest examples. So we are in the right neighborhood, just a couple kilometers from USM. So the same processes and even simpler processes are used in solar cell manufacturing. So we are world number 3. So we are big enough. We have Jinko, JA, Panasonic, QCell, and a few more companies in Malaysia. So they are all the top guns in solar PV manufacturing. So if your senior pun, some of your seniors applied physics 4th year, sebulan selepas graduated in September, I think they received the transcript. So they are now hired. I think 14 out of 19 of applied physics student final year yang baru grad baru ni are already with a job. So some of them with Cetera, some with Jinko Solar, some JA, Millets, some doing slightly different. One of them pursuing study under my supervision, doing solar cell MSc, and 14 out of 19 of them are already hired. So we are in the right neighborhood. So you should take this opportunity to develop yourself so that you are employable in like 1 year to go. So we at School of Physics also offer R&D projects at MSc and PhD levels related to what you're going to learn in this course as well, for semiconductor, optoelectronics, LEDs, solar cells, and all other devices. So this is a good fundamental for you to learn whatever you want to do, right? In fact, if you want something else out of physics, semiconductor, EE is entirely up to you as well. So we here we desire to give you the right fundamentals for you to excel in your future. Whatever field you want to do is entirely up to you, but as far as applied physics is concerned and this course is concerned, this is the foundation that we're trying to build in your in your qualification, so that you have what it takes to get a job and to survive and to in fact excel in your future, right? So yeah, that's all from me. Do you have any question about the course? You can unmute yourself and talk. Anyone? Any question? Or all clear? All clear? Ada apa-apa nak siapa-siapa nak tanya soalan, you are welcome to ask. So dalam kelas ni, even though you have, we are on Webex, kalau you ada soalan, you can just unmute yourself and ask. I welcome questions, okay? So, all right, so far so good, yeah? Semua clear? Assessment clear? Nanti as we go, I'm going to explain more and more details. Right, ada soalan, eh? Okay, good. So today is Monday. So tomorrow, okay, tomorrow, Monday 12 p.m. then. Monday 12 p.m. eh? So do you want to? I think we start the new schedule next week. Is it okay? Yep. So okay, we start the new schedule next week. So as of this week, so that means we're not going to have a class Tuesday, but we're going to have class on Wednesday as usual first, but I know that 5 of you will not be attending. Tapi I'm going to upload the file anyway to Elan, so you need to watch the file, the lecture file after the class, okay? So kita akan start new schedule next week. So maksudnya minggu ni kita akan ikut original schedule lah. Right? So no other question, right? So if that's the case, I'll see you Wednesday then. Okay? Okay, see you. Take care. Bye-bye. Assalamualaikum.